Welcome back to the shop. In today's video, I'll be starting a new project that's very steam bending intensive. I'll be building a set of shelves that can either be hung from the wall or designed to be freestanding from the floor. I like to test out what I'm trying to accomplish, and there are some pretty tight radius curves. Before I start cutting plywood and start making the forms, which will probably take me a couple of days, what I want to try to do first is test out some worst case scenario bending. This is the initial sketching that I've done. You can kind of see here, each one of these lines represents a steam bent piece of wood. This is very, very rough. And then beyond that, I just played around with using an actual compass and a straight edge and everything. And each piece, there'll be two pieces that make up each half of the shelf, and to follow my finger, the piece will serpentine back and forth all the way to the floor. Now my game plan is to achieve this is about an 11-inch diameter circle, which is an extremely tight radius even for such a thin piece. The material I'm going to be using for this mock test, I mentioned I'm trying to achieve an 11-inch diameter bend. So I'm going to break a few rules. First of all, I'm using kiln-dried wood. Second of all, this particular wood, if you were able to see it like I can see it, there's a slight bit of run out to it. In other words, the grain is exiting these two planes of the wood. Now, in an ideal situation, first of all, I'd be using air-dried wood because it bends better. When wood's kiln-drying, it sets the lignins in the wood. So I've never even attempted to bend kiln-drying wood, but that's what I'm going to do today. Second, as I mentioned, the run out, and really what I'm trying to test is it feasible in a worst case scenario? This is about a 10 1/4 inch diameter radius. Using the worst possible wood and a little bit tighter of a bending radius, I'm going to attempt to just freehand bend this wood around this form. I've got, let's see, seven different samples here, and then the third component of this worst case is I've milled this stock about 5/1000ths thicker than the ultimate 3/8 inch thickness that will make up the serpentine sides of the piece. And the reason I'm doing that, again, it's a little bit more difficult to bend thicker pieces than it is thinner. So I've already got the steam box. You can see in the upper left-hand corner. It's starting to drip, starting to spew out a little bit of steam. I'll throw these pieces into the steam box for about half an hour, and I'll take them out and I'll film my attempt to bend them around the tighter radius bucket. And we'll see how it goes. To take another second to talk about the design, what you're really looking at here is a side view, and then across each one of the circles, which these will be lapped joints, and the logic behind my 3/8 inch thickness is I plan on using a 3/8 inch diameter compression bit and a router to cut these half laps. It'd be very difficult to and time consuming to cut them by hand. The jig will be comprised of 3 3/4 inch thick pieces of plywood. I'll cut an 11-inch diameter circle. And here in this view, you can kind of see what I was planning for cauls. It's pretty difficult to freeform bend something this tight of a radius without some kind of a compression strap or some means of keeping the wood from splitting apart. So what I'll be doing in addition to these, I'll call them the bending discs, and they'll also be spaced 1 inch apart when I finally mount them to a backing board. But I'll be building cauls to essentially clamp to these tight outside radiuses, and I'll be able to clamp that caul against the form and trap the piece and hopefully contain any tear out or breaking that might occur. So again, the reason I'm doing this trial is just to kind of prove that I can get this tight of a bending radius. If not, I'll scratch the idea and I'll go with something else. But I thought this would be really cool. And across the very center line of each one of these circles, if you will, there'll be a shelf mounted in there. So these shelves will end up being about 11 and a quarter inches apart. And if we were looking at this from the front view, again, there'll be two halves connected with shelves. This will be about a half an inch thick is my goal. And the beauty of this design, if you think about this, I haven't drawn in a bracket, but let's say this is mounted to a wall and it's suspended from the top, which will also be, you can't see it in this detail, but I'm going to do a half lap joint and pin that with some dowels here at the connection point. So when I bend this around the form, I'll bend it long, trim it off later, and half lap that connection right there at the top. So if you could imagine gravity's pulling down on whatever's weighting down these shelves, the circles are going to want to compress inward like this. So if I were to pull down on this bottom, each one of these circles would become ovals and they'd get thinner in this direction. Now the strength really comes from the connection between the serpentine shaped sides, I'll call them, and the restriction of movement by the shelf between the two outer faces. Okay, so I've left the oversized kiln dried blanks in the steam box for about 45 minutes, and I've got my bucket here. I tried to secure it as best I can. And you'll see me I'll take them out one at a time. And my goal here is just to bend it 90 degrees around the bucket, hold it for a few seconds just to make sure it doesn't break. And if it doesn't break, then I should be more than good to go with my air dried lumber that has little to absolutely no grain run out at a slightly larger bending radius. So here we go. Typically you've got about a minute to form a piece. You can already tell what it's doing is as I come around these edges, it's deforming, kind of creating a peak on that outside. But this blank is behaving fairly well. The bucket doesn't take the pressure very well either. But there's one. And I would call that a fairly good success. That run out creates some of these peaks that you're seeing. Doesn't give you a real even bend, but going around a form with cauls and everything else, that ought to be just fine. So one, okay. This one's got some pretty severe run out. And I can hear it moaning and groaning as I do this. Really taking on some bad peaks. Again, the key to steam bending is getting the proper temperature, about 205, 210, and bending it pretty purposefully. And this one is definitely not good. I can hear the fibers on the outside edge severing, which is certainly not ideal. It's not completely breaking. Part of that may have had to do with, if you can pick it up, there's a small break right in this area. So that one, severe run out, not a real good example. Grab a little bit bigger piece. This one is pretty straight, and I'm hearing much less crackling. This piece being a little bit wider, it's a little bit more difficult to bend. But I'd say that is a success as well. Can't. These ends are pretty hard to control without the leverage of the additional lengths. And that one did not break. So you can see how tight that is. Success 2. Let's take out a little smaller piece. This one's got a fair bit of run out in it as well. I have a feeling these are also cooling down as I repetitively open the door. In reality, I'd be doing these one at a time, bending the whole thing, bringing the steam box back to temperature long enough to make sure that the wood is as pliable as possible. This one's got, yeah, and that would also be a failure. You can see it right there. This one is fairly straight. I can tell these are cooled down significantly. And again, I've only read that kiln dried lumber is very, very poor for bending, and that could be certain thicknesses or worse grain run out. I'm not sure, but I'm a little crack there. Pretty happy with what I'm seeing on this material, considering that it's far less than ideal. It's thicker than my actual pieces will be. It's got grain run out. And I'm really not applying even pressure with a caul. So I'd say overall this experiment certainly gives me enough confidence to proceed with building my forms. So there's another piece. A little bit of tear out on this outside face, but that's something that I could definitely live with. This one's got fairly straight grain run out, so I'm just going to try to... Oh yeah, this one's not bending. It's cooled down so much. I can tell just by the resistance. You can obviously hear it. That's a total failure right off the bat. So control the heat. Use some really nice air-dried stock that I've got. Control the grain run out and thin these pieces down a little bit. Come up with a good system of applying the force in a really quick manner. I should have pretty good success. So in my next video, I'll focus on building the jigs. It's going to take a couple sheets of plywood in order for me to build enough platform jigs to do this efficiently, but I'll walk through that process when I get there.